Thank you, Joyce. Um, I'm going to, actually, it's very fitting that my presentation comes right after food because food and water are just so tightly integrated. So I would like to make the proposition that climate crisis is also water crisis, and I would come to why I'm saying this. And overall, we would need resilient water access for adapting to and also for mitigating to climate change. I make five major arguments in this paper. This is climate crisis is also water crisis. However, as Ali Sher very nicely showed in his presentation, water is largely neglected in climate change negotiations. I knew it was largely neglected, but I did not know that it was completely neglected, like zero. So that was a good statistic to see. And I think this has implications, especially about how we are going to solve the climate crisis. If we don't characterize the crisis correctly, then how are we even going to solve it? So I make five propositions. First is climate change has led to changes in all the components of the water cycle. Basically, our water cycle as we know it has been transformed by climate change. And obviously, because every sector of the economy and every sector of the society uses water, I mean, there's nobody who doesn't need water, be it humans or nature or agriculture. Therefore, these results in these changes have affected almost all the sectors. And as our current working group 2 assessment shows, those impacts of changes on hydrological cycle on the society and economy has been mostly negative. My third proposition is majority of the people in the global south who are engaged in climate exposed occupations such as agriculture, as yesterday it quite nicely came out in Joyce's presentation as well, because in the global south, majority of the people earn their livelihoods from agriculture. So they are actually experiencing climate change through water. My fourth proposition is that water is a part of the problem, but water is also a part of the solution. Majority of the adaptation are also using water to adapt. Farmers use irrigation to adapt. Farmers are doing rainwater harvesting, urban buildings. I mean, a lot of the presentation that Barbara just now made around nature-based solution had water as an integral part. So water is also a part of the solution. And my final proposition would be most mitigation measures, including many of these nature-based ones, such as forestation, bioenergy, all of these can have a high water footprint, which is rarely discussed. So I would go one by one with each of these propositions and try to substantiate them with with data. First is that this is a figure from our water chapter in the working group 2, where we are showing that all components of the water cycle have been affected by climate change. I give some specific examples. The first one is of heavy precipitation. This is a figure from the working group 1 IPCC summary for policymakers. And in this, you can see that pretty much there are a lot of those parts of the world, all those that are colored in green, are the ones that have experienced increase in heavy precipitation. So one of the things that global warming is doing to water cycle is it basically intensifying the water cycle. There is just more moisture in the atmosphere, and a large part of the world is experiencing heavy precipitation since the 1950s. The parts that are not shown as not the gray parts, I mean, it's not to say that those gray parts do not experience similar change. It's just that there isn't enough data in those areas. So that also talks about the need for greater data generation in entire parts of Africa and Latin America. So the first point is around heavy precipitation. Similarly, the working group 1 SPM also shows that a large part of the world has also experienced an increase in droughts. It could be increase in duration of droughts as well as increase in intensity of droughts. Again, wherever you are seeing low agreement, it may not be about that those areas have not experienced drought. It's just a matter of science catching up with what's happening at the ground level. It's also a matter of how good data you have, how old the database is, and all of that. So absence of evidence is basically not equivalent to droughts not happening in those regions, just to be clear here. The third important way in which a water cycle is getting changed is through the melting of the cryosphere. Cryosphere, as we know, is the frozen part of the water cycle. And glaciers are melting at unprecedented rates, including where I come from, the Hindu Kush Himalayas, and this is affecting the ways and cultures of lives of people. These are in the high mountains that you also have a lot of ethnic minorities living. So, and they depend a lot on those water resources. So that's this is a figure from our water chapter in the working group too. So this is and figures like these you will see in all the mountain ranges. This is a photograph of the Mount Everest in 1921 from, I think, Royal Geographical Society. And then almost, if you go down roughly 100 years down the line, this is what is happening. So all the ice is melting, and what you have left is like the glacial lake. So I can show it again. This happens to be one of my favorite sad figures. But if you keep your eyes at one point of this figure, and then you see how these changes are, and these changes are ubiquitous, happening in the Alps to some extent, Andes to a large extent, to the Himalayas. And then finally, what will happen is that all the projections are more or less clear that water cycle will continue to intensify at higher levels of global warming, making making further changes in mean precipitation, soil moisture, floods, droughts, etc. So that's my first argument, that water cycle has been affected deeply by climate change. My second okay, and then already we have to remember that 4 billion people experience severe water scarcity, and this is a part of it is climatic, but a lot of it is also non-climatic factors. So we are already starting this thing with half the world experiencing water scarcity at some point of the year. So it's already quite grave, and climate change is making it even worse. Now, coming to the second argument is that our assessment in the IPCC showed very clearly that all sectors of the economy and society, especially in the global south, are feeling negative impacts of changes in water cycle. Particularly this part, this may be a bit too small to see, but we have assessed the water-related changes in agriculture, energy, in health and hygiene. We have assessed it in urban and in ecosystems, and in almost everything you can see that the impacts have been negative. The level of confidence varies, and that really depends on the nature of the literature. But overall, the impacts of climate change and all the sectors of the economy and society have been negative. To give some examples, this is from our assessment. We find that in agriculture, 3/4 of global harvested land experienced drought-related agricultural losses between 1983 to 2009, with production loss of 9 to 10% due to weather extremes alone. And here we are only considering water-related extremes, not really the heat-related extremes. In energy, again, between 1981 to 2000, literature shows that that up to 5% of hydropower production goes down in drought years compared to normal years. And this is actually much worse in thermal plants. Thermal plants actually are much more sensitive to water scarcity. On health, and yesterday Robin presented it very nicely, extreme events like floods are linked with increased incidence of water-related diseases. I think this is also fairly well established. In urban areas, which we also know are the ones which are hotspots of water-related disasters, we have found that 17% of the cities experience statistically significant increases in extreme precipitation between 1973 to 2012. Similarly, in freshwater ecosystems, between 1970 to 2015, 35% of wetland area decline, with climate change being an important driver. Obviously, climate change is not the only driver for wetland decline. There are other drivers, but climate change is increasingly an important driver. So this makes me come to my third point, which is impacts of changing water cycle are being felt disproportionately by women, poor farmers, indigenous people. This has been a point, I think, has been a constant discourse around equity and who feels the impacts. So this was again a figure from our water chapter where we are showing that in the high mountain regions, these are some of the indigenous people. Some of them tend to be very marginalized given their geography, given the colonial history, and given a huge, like a long history of exploitation. And these are some of the communities who depend on these cryosphere resources are getting hugely impacted. I apologize for very short, very small font, but this is just a snapshot of the case studies that we looked at from various parts of the world. This is a particular community. I have worked in Ladakh in India, and you see, this is so picturesque. And that green verdant valley in between, that literally depends on those tiny bits of glaciers that and snow you can see on the top of the faraway mountains. But traditionally, for over thousands of years, they have a very detailed system of irrigation. They have a system of bringing water from the snowmelt through kilometers long channels and tunnels. And that's how this entire irrigation in these small villages are sustained. And now this have become almost impossible to sustain because the ice melts faster. It melts while it's still very cold, and it's like the seeds are not yet ready to germinate. So entire cropping season has become much shorter than it used to be earlier, and farmers are facing a whole lot of difficulties. And here during our field work, I remember a group of elderly men were asking, so what can we do uh, to adapt? And the answer is that these are precisely the areas where limits to adaptations have been reached, like real hard physical limits to adaptation. How do you adapt when the glaciers you depend on melts? So, and these are the ones who are most vulnerable, as we know, have not contributed to carbon emissions at all, and they are facing the most severe impact. Coming to my fourth important point, which is that water is also central to adaptation. I don't know how it is understood. I mean, the water community understands it very well, but it's not often very well understood among the wider community, the important role that water plays. We did, this is again a part of the IPCC assessment, we did a meta review of over 2,000 articles, 1,800, 1,900 articles, and we found that majority of the adaptation is happening in response to a water hazard. Those hazards could be droughts, precipitation variability, floods, groundwater, melting of cryosphere. So water is what people are adapting to, because farmers actually, like for majority of the climate exposed occupations, it's water that they are, like they face the impact of climate change through water. And we found that documented cases of these water-related adaptation is happening in all regions, and more so in Africa and Asia, where there is a high dependence on climate-exposed livelihoods like agriculture. Again, most of the water adaptation in global south is in agriculture, while most of the adaptation in global north is in urban sector and related to floods. Again, pretty obvious, but the huge literature survey also confirms these kind of these kind of findings that we were already aware of. Now, this also brings me something to what Robin yesterday mentioned about the real difficulty of knowing whether adaptation has worked. So we found over 2,000 studies around adaptation, but only a handful of them, around 300 or so studies, actually measure outcomes. And of that, only around 70 of them actually measure outcomes in a causal way. Majority of them are either simple correlation or case studies without causal attribution. So in this assessment, we ended up concluding we were not able to actually measure effectiveness of adaptation. But what we could find was that water-related adaptation have many benefits. But we do not know if they reduce climate risks. I think that is an important point, whether adaptation is reducing risk, and this can be a major area of work for the future and something that the IPCC AR7 needs to take up, like how effective are adaptation in reducing risk. And this is something I thought was a new contribution this time, that we also looked in very much detail the effectiveness of future adaptation. Now, when I go to adaptation, sorry, I don't know. The fonts are a bit too small. I just profusely apologize for that. But in the x-axis, sorry, in the rows, what you are seeing is 16 major adaptation types. They include things like improved cultivars, then agronomic practices, irrigation, water management, collective action, migration, economic and financial incentives, agroforestry, flood risk. So those are all the ones that we assessed with the help of published literature. So we did a similar assessment for whatever studies were available for future effectiveness of adaptation. For one, there is a difficulty here because we do not have as much studies looking at future effectiveness of adaptation as we have about current effectiveness. So for our 2000 studies for current adaptation, we had only 45 studies for future adaptation. And in those 45 studies, and again, I think yesterday Susan said that IPCC makes beautiful figures but completely unreadable. So I think this is another one of those unreadable figures. So don't even read it. What you do is try to look at that, like from the top to bottom is kind of the degree centigrade, like global warming. And if you just keep a look on the red part, red is residual risk. The blue part is like how much is those, at what temperature would adaptation remain effective in reducing risk. So as you see that from top to bottom, the blue sections keep coming down, adaptation becomes less and less effective in reducing risk, while the red part of it goes up. That is, the residual risks after adaptation increase, very much at a higher level. So this brings back to some of the discussions we are having yesterday around the fact that adaptation can only do so much. At a higher level of global warming, our scope for adaptation will get limited severely. So we cannot even adapt. At 4 degree, many of these adaptations remain hardly viable. So I mean, what are we talking about? 4 degrees not something that is at all feasible. I mean, it should be almost banned to be talking about a 4 degree future, because there is no future. And also mountains where I have worked extensively in, even 1.5 degrees too high for the Himalayas. Even at 1.5 degree, 50% glaciers melt by the end of 2100. So, I mean, it's like 3 degree, 4 degrees are simply not options. So this is the same point where we compare the effectiveness, rather benefits in the current and effectiveness in the future. And the main thing we are showing is that the residual risk actually increase substantially at higher degrees of global warming. Now I come to my final point, which is around mitigation. So far we have talked, to recap, around how water cycle has been affected, how every sector has been affected, how the poor and the vulnerable and the indigenous people has been disproportionately affected. Then we talked about how important water is to adaptation. Now I come to water is also very important in mitigation and almost completely overlooked. So most mitigation measures, including carbon dioxide removal approaches and technologies, have large trade-offs with water and food security. We state in our chapter with medium evidence high agreement which makes it a medium confidence statement, that many mitigation measures have considerable water footprint. No, this is a high confidence statement actually, which must be managed in socially and politically accepted ways to reduce those impacts. To give you some concrete example, one is bioenergy crops, which is a part of BECS, etc. So bioenergy crop, one study, this is just one study, but it kind of shows that bioenergy crops, along with some other nature-based solutions, can potentially limit global warming by the end of century to 1.5, but it can potentially also double the global area and population living under severe water stress. And you have to remember that already 50% of the population faces severe water stress for at least some part of the year. So that's not even an option, that water stress increases even further. And studies also show that bioenergy crops can significantly impact food prices via demand for land and water. Similar is the case for afforestation, reforestation. Again, I think it's a great solution, but we have to be just very careful where we are deploying it. If done at inappropriate locations or inappropriate species, then it can lead to trade-offs between land biodiversity and water resources. For example, a global assessment on forest and water reiterated that we have to manage forests not just for carbon, but also for water, and they concluded that afforestation and reforestation should be concentrated in water abundant locations and where transpiration can potentially be captured downwind as precipitation. So that was one of the reasons that I was asking about the great, the African initiative of these forests in the Sahel. And I was wondering, Great Green Wall, and I was wondering about the water impacts of that, or whether the regional ones. Yeah. So I would conclude here that water is an integral part of resilience and needs to be more visible in climate negotiations. So just the recap of the main points again: climate change is experienced first and foremost by changes in water regimes by a large majority of people in the global south. I'm talking of farmers, fisher folk, and those are the ones, like 60-70% of our farmers of our populations are just that, farmers, fisher folk, foresters, they depend on primary resources. So since the most vulnerable feel impacts through water in some ways, access to water in some ways also becomes the vehicle through which climate injustice propagates. And my third conclusion is that water is indeed a part of the problem, but is also a large part of the solution. So we also need to focus on water as a solution. And finally, while mitigation is absolutely the need of the hour, we know that this is the decade of mitigation. We have to do everything we can to keep within, 1.5 degree. But if not well planned, some mitigation measures can make local water and food security even worse through high water footprints. So water needs a seat at the mitigation table. So I'll stop there. Thank you.